Sometimes when we're solving inequalities algebraically, it's helpful to see the solutions on a number line to get a better idea of what answers work. So let me write an example. Let's say we had 2x plus 1 is less than 13. Now, of course, normally we say 2x plus 1 equals 13, and we solve it, and the answer is going to be 6. And if it were an equal sign, we would just say, okay, the solution is 6. But when we say we want the whole set where the x's we plug in will give us a number less than 13, well, now there's an infinite number of answers that will work. So we are going to solve this, and I just urge you to start by kind of imagining that less than can be just worked around as if it were an equal sign. And it's just going to remain that less than sign, but we're going to just kind of ignore that it exists here for a minute. We're going to subtract 1 from both sides, like always, so that we have 2x is less than 12. So notice I just brought that less than down like that. Then, like always, we're going to divide both sides by 2. So I have x is less than 6. Again, this just dropped down like that. So now we don't have just that 6. We've got all of the x's that are less than 6. Now, in an earlier video, I talked about how we graph these inequalities, but let me just quick remind you, when we have a less than, but we don't have an equal sign, less than but not equal, we use an open circle. So I'm going to put an open circle on 6 like that. And then we are looking for all of the numbers that are less than that. So we're going to just draw like this. And maybe put an arrow. We're talking about all the numbers less than 6. So any number below 6 will make this true. So let's say you plugged in 0. 2 times 0 plus 1 is 1, and that's less than 13. If you plugged in negative 5, 2 times negative 5 is negative 10, plus 1 is negative 9. That's less than 13. So it is all of the answers down in here. Let's do another example. So 4x minus 3 is greater than or equal to negative 15. So again, we're going to be graphing an entire solution set. Now, let's just begin by saying, all right, we're going to kind of ignore that and work around it. So we're going to begin by adding 3 to both sides. Then we're going to divide both sides by 4. And we'll have x is greater than or equal to negative 3. Now, because it's a greater than or equal to, we're going to go to negative 3 and we're going to put a filled in circle. So something like that. And then it's all the numbers greater than that, so all of the numbers up here. And this is the entire solution set that will work. So again, I always like to plug in 0. 4 times 0 minus 3 is negative 3, and that is greater than negative 15. So all of the numbers up here, any number plugged in, will make this a true statement. Let's do another. All right. In this problem, we have negative 3x plus 4 is greater than negative 2. I have thrown one wrinkle in here that we'll get to in one step. But let's begin by just proceeding like we'd solve any other algebra problem, subtracting 4 from both sides. So we have negative 3x is greater than negative 6. And now we'll divide by negative 3. But this is going to cause one thing to happen. When numbers are multiplied by a negative, it changes their sign. If we had, a positive number here and multiplied it by negative 3, that would flip it to be a negative output. If we plugged in a negative number for x, multiplying it by a negative would flip it to be a positive output. That changing of the sign basically reverses us on a number line. So if you think about, I plugged in a positive x and suddenly I got a number that was down here negative. Or I plugged in a negative x, but when I multiplied it, I reflected myself up here positive. When I divide by a negative number, like you normally would, you'll still get your x and you'll still get a 2, but your inequality sign will have to flip to reflect that you changed the sign. And this is a rule that most people just memorize. It's not something you need to think about all the time. Just remember, whenever you divide by a negative, right there, you have to reverse your inequality, its direction. So notice that it just flipped directions. And again, the reason is multiplying by that negative, or having that negative there, reverses our side of the number line, because multiplying by a negative changes the sign of the output. So just remember that every time. You don't need to necessarily remember and memorize the reason. I just want you to know why that's going to happen. So x is less than 2. So less than 2. We're going to have an open circle at 2. Let me do that. And then it's all the numbers less than that. Okay, let's verify that what we did is true. Let's plug in, let's say negative 1. Let's plug in negative 1. Negative 3 times negative 1 is positive 3. Plus 4 is 7, and that is greater than negative 2. If we had forgotten to reverse our inequality, let's say we left it and we'd accidentally shaded up here. What if we'd plugged in 4? Negative 3 times 4 is negative 12. Negative 12 plus 4 is negative 8. That isn't bigger than negative 2. And that's why we had to do that, because plugging in these values up here would get multiplied by a negative, and that flips us to the other side of our number line. Let's do one more example where this happens, because I think it's worth practicing. Okay, negative 2x plus 7 is less than or equal to 13. So first thing let's do, let's subtract 7 from both sides. And we'll have negative 2x is less than or equal to 6. And now I will divide both sides by negative 2. Again, dividing by the negative flips us on the number line. So this divides out. We still have x. We still have negative 3. But our inequality will flip signs. Again, whenever you divide by a negative to get the answer, you have to reverse this inequality, because we have reversed the sign of the output. So it will be greater than or equal to negative 3. So let's go to negative 3. We're going to do a filled in circle because it is equal to. And these are all the numbers that are bigger than that. So let's do this. And let's verify that that worked. I always like to verify that we got it right. Let's say we plugged in negative 1. Negative 2 times negative 1 is positive 2. Plus 7 is 9. That's less than 13. Let's go down here to the wrong side and plug in a number. Let's plug in negative 6. Negative 2 times negative 6 is 12. Plus 7 is 19. That isn't less than 13. And again, it's because of that multiplication right here. The minute we multiply our x's by a negative, we reverse the sign. And that's what makes the inequality reverse. So if you have a positive number, let's say it was just positive 2 and positive 2. When we divide by 2, we don't change the inequality because there was no reversal of sign. It's only when there is a negative that we're dividing by. If this video helped you, please like and subscribe for more math help.